When people talk about Web3 applications, one term comes up again and again: smart contracts. But despite the name, smart contracts aren't really contracts in the legal sense, and they're not particularly smart either. So let's break down what they actually are and why they exist. At their core, a smart contract is just a piece of code that lives on a blockchain and runs automatically when certain conditions are met. Instead of relying on a person, a company, or an intermediary to enforce rules, the rules are written directly into code, and the blockchain guarantees that the code executes exactly as written. For example, a smart contract might say, if this address sends funds, then release this asset, or if these conditions are met, update the state of this application. The most primitive example would be to expect a drink or food item to fall out of a vending machine once you've put in the required money to purchase said item. Once a smart contract is deployed, that logic runs without human intervention. This idea was first formally described by a computer scientist, Nick Szabo, in the 1990s, long before blockchains existed, and later became practical with platforms like Ethereum, which allowed arbitrary code to be executed on-chain. According to Andreas Antonopoulos in his book Mastering Ethereum, smart contracts are programs that control digital assets and execute deterministically across a decentralized network, meaning every node reaches the same result without trusting a central authority. In practice, smart contracts are what enable things like decentralized exchanges, lending protocols, NFTs, and DAOs. Instead of trusting a company to custody funds or enforce rules, users interact directly with code that anyone can expect and verify. That transparency is a big part of their appeal. However, it's important to understand the trade-offs. Smart contracts are immutable once deployed, which means bugs can't easily be fixed, and mistakes can be very expensive. They also introduce complexity. Every interaction with a smart contract requires computation on the network, which is why many blockchains charge variable fees, often called gas fees, to prevent spam and manage limited block space. This makes smart contracts powerful, but not always user-friendly. Quick pause here. If this explanation is helping you understand how Web3 applications actually function under the hood, take a second to subscribe, because this channel is all about building a real understanding in Web3. Now, back to smart contracts. Another important thing to grasp is that smart contracts are just one design choice, not a requirement for decentralization. They solve a specific problem: how to coordinate logic and assets without intermediaries. But they're not always the best tool for every job, and they come with real trade-offs in terms of cost, complexity, and risk. Understanding smart contracts isn't about deciding whether you love them or hate them. It's about deciding and knowing what they do, why they exist, and what problems they're trying to solve. Once you understand that, you're much better equipped to evaluate different blockchain architectures and application designs. In simple terms, smart contracts are automated rules enforced by a blockchain, replacing trust in people with trust in code. And whether a system uses them heavily, sparingly, or not at all, knowing how smart contracts works is a key piece of Web3 literacy. If you want more clear, no-nonsense explanations like this one, make sure you're subscribed. We're building this knowledge base video by video. See you in the next one.